Now in number 9, we're moving on to looking at an actual equation for a function and trying to decide if it's even, odd, or neither. Now remember what we said about odd functions. An odd function, f of negative x, is the same as negative f of x. For an even function, f of negative x is the same as f of x. And for neither, you can imagine that neither one of those holds true. Okay? Alright, so now let's take a look at the functions that we have here. And if you think about the sine function, we know that for a sine function, the sine of negative x is equal to negative sine of x. Okay, we know that to be true of our sine function. We know that it is an odd function and that it is symmetric with respect to the origin. So now let's look at the other part of the function, which is the x to the third part, and let's see what would happen if we plugged in a negative x to the third there. Would that be the same as negative x to the third? And the answer is yes, it would, and therefore a is an odd function, both of its parts being odd. Looking at number 2, or I'm sorry, part B, where you have x squared minus 4, if you think about that function and you were to plug in a negative x value and square it, subtract 4, you would get exactly the same thing as if you plugged in the x value, the equivalent x value. These would come out exactly the same. Therefore, this is an even function and would be symmetric with respect to the y-axis, which we would expect from a parabola. In part C, notice that we have two different types of functions here. We have the cosine function, which cosine of negative x would be equal to cosine of x. Therefore, that part of our function would be even. But then, if you look at the other part, you have 4 times negative x would be equal to negative 4 times x, and that part of the function would be odd. Therefore, this function is neither.